All right, welcome everybody to the March PD&E webinar. I have the honor of introducing our speakers today. So let me tell you a little bit about them. Tammy is principal architect with J.E. Dunn's industrial and manufacturing team, and she works closely with design partners from their project's earliest stages, providing input on employee experience, process flow, and efficiency. Tammy has spent more than 25 years in the design build world and brings a unique understanding from both perspectives. She's instrumental in constructability reviews and ensuring that tie-ins to existing facilities are executed seamlessly. Tammy is also an expert in the design of distribution and cold storage facilities and offers a wealth of knowledge around retrofit and addition and renovation work on active production facilities. Tammy holds a bachelor's degree in architecture from the University of Cincinnati. She's a registered architect in multiple states and is a Design Build Institute of America accredited professional. Kate Lowe is senior estimator MEP pre-construction at Holder Construction Design Build. Kate works on mission-critical facilities across the country, specializing in the electrical design trades. Kate is passionate about promoting the construction industry as an accessible career path for young men and women. She's a dynamic, engaging, and educationally minded professional who has a personal mission to share opportunities related to learning trade principles. She's also a strong advocate for women in the construction industry and has been recognized for her leadership and community service. She's currently serving as NAWIC Atlanta Chapter number 49's president and Professional Development and Education Chair. So thank you all so much for being here today. And without further ado, I'm going to turn it over to Tammy and Kate.
Thanks, Abba. I appreciate it. Great welcoming. Hi, guys. We're excited to have you. Just want to make sure everybody can see my screen, right? Thumbs up. Perfect. Okay, great. So welcome to Commercial Blueprint Reading Series. So I've been pre-con focused my entire career. Little background, I've worked in the trades, manufacturing, general contracting, and development before I came here to Holder recently, where I'm a part of MEP electrical lead for design build facility. So really, really cool. Tammy and I are going to be leading this class from a global team perspective. So sometimes you're going to have different insight at different points. People are brought into drawings at different series or levels. So you'll hear us talk about from the full design to like how it may relate to the superintendent and the project team. So that's kind of that global perspective that we're going to take. So let's dig in. All right. What's a blueprint? Blueprint is a 2D representation of a 3D build. The design team must relay information to each trade, general contractor, and owner to ensure they are building a code-compliant as-designed building that's stated, shown, and directed in the same way. So that's going to be Tammy's job. So, we'll discuss is what the pages are showing you, what it really means, how the disciplines are working, and give you an idea of what the components are in the building so that we can assemble a code compliant commercial build from the foundation to the MEP systems. So it's just a little overview of what we're doing today. So I love my job because I pretend that I play Where's Waldo every single day. I look for symbols to try to figure out what something is, what it means, and what it affects. So that will lead to us maybe jumping through some multiple pages as Tammy takes you through the architectural. But we're going to discuss what the blueprint is today. Another point of view that I take for my job is I play detective all day. So I'm looking for the what, the why, the how, and the are you sure? So that's kind of what we're looking at. So that's kind of the way that I like to see my job. And if y'all have questions, go ahead and put them in the chat because we are monitoring that. So the slide you're seeing now is these are all of the disciplines in a construction set of drawings. So the ones that are highlighted are typically the discipline set. So you're going to see general drawings that will give you basic information. You're going to see civil drawings. That's going to be your site and your landscaping. Architectural drawings. That's going to be your basic floor plan, structural drawings, how the building is coming together from foundation to kind of bones of the building, steel, wood, however that is, and then the roof. And then MEP has their own set of disciplines. So essentially the hierarchy, and Tammy is going to get into this, but the architect is in charge of all of that, and the engineers do their individual pieces that the architect then has to tie to make sure that everything is in the right place. So you have multiple trades in every discipline set. So like civil, for example, will have your grading, your landscaper, asphalt, roadways. Structural, you're going to see steel, roofing, concrete, and wood. Architectural will be flooring, paint, and drywall. All the finishes and basic overlay of what is intended to look like after the fact. And MEP is the functionality of our building. So that's mechanical, electrical, and plumbing. Okay, so there are 3 sets of process planning. So as you heard Ava introduce, me and Tammy both work with design build. So there's really 3 sets. It's called schematic design, SD, which essentially you're building as your architectural engineers engage, but usually they're at 30 to 55% kind of what they want to do, what the owner wants to do. But they really haven't figured out much more than a floor plan, the size, and the intention of the building outside of maybe where. A DD set is a design development set. And that's really like 60% plus. We know where the rooms are going. We know the functionality of the building. We're trying to figure out all the specific systems required and meeting municipality code. And then the most popular that most everybody on this call should see is your CD set, or your construction document set. And that is a set that's already gone through all of planning and procurement, or I'm sorry, planning, review, zoning for what we call authority having jurisdictions, that's your state, your county. It's already been looked at and approved by all your architects and engineers, stamped and ready to go. All right, so jumping right in. I'm not going to hit this too hard because Tammy is going to, but this is essentially your G page, so general page. So things that we're looking at, this is your formal project name. It will always be at the top. Something that you're also always going to see is to the right. So starting at the top right, this is telling me who my architect is. Then I've got this set of drawing dates. So whatever they're dated is the most revision set that I'm working with. The name of the page, and then bottom right is the actual page number. So this set also shows us our point of contact, so who the architects and engineers are. And this is essentially our table of contents, what each page is, what's included in the set. And here we have a vicinity map. So your vicinity map is showing you basic topography of what we're looking at. So a little closer up of that is usually your building won't have an address. There's no postal code to say where your material is being delivered. So we use these vicinity maps that give us an idea of the highway, the landmark, and your local surroundings to figure out where your building is. And then I just kind of snippeted these so y'all could see what the project team was and how that looked. Every discipline set, so that's either your G page, your A page, your structural, or your MEP, they're all going to have different immediate needs. So they're all going to have their own abbreviations. They're going to all have their own 00 page, which will give you basic information. And that is your engineer, your architect specifically saying, hey, contractor, hey, GC, hey, supplier, don't miss this. This is only for this set. So you're going to see the A pages have their own set of abbreviations. So just a couple examples. ACT is your acoustical tile ceiling. AFF is above finished floor. Some really like standard ones that we'll see is TYP, typical, or UNO, unless noted otherwise. Those are kind of your standards that you're seeing. They may or may not be used. They typically are boilerplate, but it's a good tip that you always want to snippet it, print it, save it, so that when you see it through your page and playing Where's Waldo, a detective, you're like, what is that? Oh, got it right here, ready to go. So the other thing that I always really like to talk about with everybody is there are so many different viewpoints, right? So again, your architect and your engineer has to ensure that everybody is reading how to build this building the same way. So they will use the viewpoints based on that. So whether you have a CD set or a DD set, you're going to see different viewpoints. I did want to hit on all of these. So this is your floor plan. Okay, so this really gives you an idea of what is supposed to be there. So this is actually a medical building, and it's got operational, you know, where the dentist desk chairs are. We see the hallway, we can see the individual rooms, gives us an idea. And then I just kind of took little snippets from other places because like this is your radiology lab. So this is an overview. So as if like we are, you know, horizontal slice of the building, like a dollhouse, we're just gonna lift that roof up and like we're just hovering over the building. So I can see we have a restroom, hallway restroom, electrical room. And then we can even see, this is actually millwork. So it looks like a countertop and a sink. And again, all of these will be on your 00 page, and Tammy's going to talk about that, but I can see a door. So again, it's just lift up the dollhouse. And then this, I liked this one because it's actually millwork for a built-in desk for reception. So I thought that was a good one to show y'all also. So we're going to go through all of those. So your most common view is the one we just talked about. So it's a plan view. Plan view is going to be your most common. It's looking down through the building as a horizontal slice, and you're looking directly over it. Okay, so I like the dollhouse assembly or drone or whatever y'all like to think about. So typically it is an X-ray view, as if you took the roof off and you put the ceiling off and you're hovering right above. So you can see walls, flooring, millwork, like we just talked about, equipment. A lot of other times you're going to see different plan views, really common on the A pages or the architectural pages, and that's your roof plan where you're like hovering right above the roof so you can see what's sitting on it. It's still a horizontal slice, but it's not really an X-ray slice. Right, and then we have elevation view. So your elevation view is a vertical slice, right? As if you're standing directly in front of the building, or you're standing in the parking lot, you're standing right outside the door. So it's the exterior vertical slice, and you can see the interior elevations. You can see from floor to the roof, it tells us it's 15.2, and then to this roof screen, it's from 0, it's 23.3. So he gives us information, you know, top of canopy, top of window, top of door. But really what your elevation view is showing you is what the building's supposed to look like. Like what is the intention of the architect for this building to look like? And then we extrapolate or we get some deeper information also from these pages. So this is an exterior, and then this is an interior. So again, your interior, this is that reception desk that we talked about. So it shows you it's got cabinets, it's got drawers, it's got plastic laminate top. So it's same POV, it's just inside the building versus outside the building. And this will always tell you the design aesthetic that they're going for. The other viewpoint you're going to see is a section view. So that's an interior elevation, vertical slice through the building. So this is definitely X-rayed, right? So all we're looking at is I can see what is X-rayed in the building. So again, it's sliced as if we're looking straight through with X-ray glasses. So you can see ceiling height, structural height, or any indicator that the architect wants to bring forward. Section views, again, it's a vertical slice, but it's more minute part of the building. So it's essentially looking at an itty bitty part. So I extracted this. So it showed us this whole exterior wall. And then it showed us another piece of the wall and then a further detail piece of the wall. So if we're looking at this from the elevation view, I don't have a lot of detail about the material. But if we go next, I do get some more information, and there's going to be a legend and an abbreviation for all of these. And then Tammy's going to get into all that. But what you can see is joist, tie-ins, windows, foundation, insulation, waterproofing. You've got multiple sub-trades here. So that's kind of a way for an architect or an engineer to say, again, hey, contractor, don't miss this because you got 4 or 5 trades all in the same area. So by them zooming in to that section view, it's telling them more detail on how to construct it. And then so a detail view is an even more minute factor of a section view. So it's going to give us even more information. So like we zoomed in here and now I can see steel beams inside of this canopy. I can see metal coping. I can see, it's just a further point of view. We're just microing in on more of those details. So again, it's going to be a more finite detail than a section view. A section view is going to be more of a finite detail than an elevation view. And an elevation view is different from the plan view. That's where we're looking in and dollhouse up. So again, we're playing Where's Waldo throughout, but these are where you find your clues. So if you skip over the detail in the sections, you're missing money. Okay, another thing that we're going to see are schedules. So the most common schedule are room finish schedules. It'll tell you room number, room name, flooring, wall, finishes, and then door schedules. So again, it'll give you door information, a lot of different door types, hardware schedules. Every discipline will have its own set of schedules. Your mechanical schedule is different than your electrical schedule. Your finish schedule is different than your roofing schedule. Your roofing schedule is different than your steel schedule. So it's all, you're always going to look in those specific disciplines. But again, that's just a way of the architect and the engineering saying, hey, Mr. Contractor, Ms. Contractor, do not miss this. This is important. It's just for you, very project specific. Other than that, I'm going to let Tammy have it. If y'all have any questions, go ahead and put them in the chat.
Thanks, Kate. So now we're going to jump into the actual drawing set. So we're going to be looking at a live PDF set, and today we're going to be covering the architectural and structural drawings out of this set. So please do put on your calendar and join us April 9th for our next session, where we'll be taking a deeper dive into the mechanical, electrical, and plumbing drawings. So the architectural set that we're going to look at first, that is where we're getting all of our building organization information. So the architectural set is going to show you the space layout. It's going to show you where the walls go, what materials the building is made of, and how you get in and out and move around the building. So Kate touched on the cover sheet, a lot of really good important information here. One additional thing I wanted to note, sometimes this is on the cover sheet, sometimes you'll find it on the life safety sheet, but the architect will typically give you some sort of project summary, which is just a general description of what the building is. So in our case, we know we're building a single-story addition to an existing building. So that's what we're going to be looking at today. And we know this is a dental hygiene teaching lab. So those are some clues as we're looking at things and wondering maybe what is that? You know, we can be thinking about what would you find in a dental lab, or what would you find at your dentist's office? So this is what that full page of abbreviations looks like. Really important information, and Kate's absolutely right. You want to have this handy really at all times as you're flipping through this set, because you're going to be referring back to these abbreviations a lot. It's also important to note these symbols and this legend here. This also gives you additional information about what you're looking at, what these different tags mean. Elements, building components are going to have different tags that can tie back to schedule information that Kate was showing us, that gives us all of that additional information. So it's important to know, like, which specific door are we looking at when we're looking at the door schedule. And we can see where those section cuts are taken, where those slices through the building are taken, and where the elevations are, which wall exactly are we looking at. So really important information on this sheet. A lot of these symbols are industry standard, but it's important to make sure you're always looking at your project specific ones, because as architects, we do like to occasionally get a little bit fancy. So it may not be consistent from project to project. So this is your life safety plan. And there's a lot of good information here. It's not just code related information. It shows you the general arrangement of the building. It shows you how you're going to get in and out of the building. But there's also good information about the building itself, about what construction type it is. And you can also find your square footages here. So if you're doing takeoffs or if you're doing estimating, really good, quick and handy reference information to find on this page. Now our overall floor plan. So this is showing us, again, this is that dollhouse view. We've taken the roof off and we're looking down on it. So this information is showing us our layout. It's showing us our dimensions. It's showing us where the walls go, what the walls are made of. We've got some tags that reference back to schedules that show us that. It's going to be showing us the door and window information, and it's going to be providing us the locations of references where we can find more detail. Now, the important thing to remember when you're looking at these sets, there's a lot of information here. There's a lot of lines, there's a lot of symbols, there's a lot of tags. And when you're first looking at it, it can be really confusing. But the important thing really is just remember, take it one piece at a time. Allow yourself time to flip back and forth through the pages. You're going to be doing that a lot as you're looking at the different sets. You're going to be going to look at that granular detail, coming back to the floor plan to orient yourself, moving on to the next piece. So really allow yourself that time. So here we see we've got some section cuts that show us the slices through the building. We've got some elevation views that show us as we're looking at the building, at that exterior wall, we can see those symbols. And we can also see these dashed lines highlighting certain areas that show us there's some additional information in enlarged view that shows us a little bit more granular information. So when we're playing Where's Waldo, we like to think of these as our side quests, where we can pick up some extra coins and really get a lot of extra information. Also important to note on this page before we dive into one of these enlarged views, when you see something grayed out on a plan, it is often either the existing building or the architect is telling you that this is not in the project scope. So they're graying it out, saying ignore this part of the building. We know we have an addition here, so we know that's our existing building. So let's take a look at an enlarged plan of this area, which is this A1, A1112. So here's your Bluebeam hack for the day. If you didn't know Bluebeam could do this, you can ask your architects when they print the set to hyperlink, to check the box that hyperlinks all of their tags. And what that will allow you to do is to click directly on the tag and it'll take you straight to that page. So that is super handy when you're trying to save some time flipping through back and forth through all of the pages. So we were looking at that A1. We can see here in our detail title, we found the A1. It's an enlarged plan, so it tells us what type of view it is. And we can see here, as we're looking at this, now we can start to see some graphic representation of our different materials. We can see our doors. Our doors will typically show us the swing, so it shows us which way the door is opening into or out of the room. We can see our tags. We can see them a little bit more clearly now because we're looking at a larger view, so things are a little bit easier to see. We can also see some of our windows, so we can see what our windows look like. We have two different types of windows on this project, so they're shown slightly differently, but we can see that graphic representation. So we can see our mullions here, which are the vertical pieces or horizontal pieces between that hold the different panes of glass together. We can see our wall types, so we've got some tags that reference what our wall types are. And as you look at these different notes, you'll also see that there's some specific notes. Now, what's important to know on each page as you're looking at it is that there are going to be page-specific or sheet-specific notes and keynotes. So in this case, for example, this says note number 6. We know we have some sheet-specific notes. We can go here, see note number 6 is a coat hook. So that's important information. It may seem like a minor detail, but when the building is finished and the owners walk in and don't have a coat hook, they're not going to be very happy. So really important to pay attention to the sheet specific notes and then look at your keynotes. So keynotes are what the architect will use rather than having to type out the same note every time and really clutter up the sheet with a lot of words. They'll use keynotes and then provide a legend that tells you what the different elements are that they've noted. So do pay attention to those items. Again, we're drilling into greater detail now. So we talked a little bit about, this was the millwork that Kate highlighted for us earlier. So you're going to see a lot of dashed lines on the drawings, and they all kind of mean different things. It could mean something's not in contract. It could mean it's something that's overhead, or it could mean something that's down below. We'll also use dashed lines as architects to show what our clearances are for accessibility. So it's really using that drawing set as a whole that gives you the clues to understand what the particular dashed lines mean for each thing. So in this case, we know there's going to be an interior elevation of this millwork. We looked at it a little bit earlier. You may have caught that there were some section cuts that'll give us some more detail. So we can kind of drill down into those specific components to make sure that we understand what all those dashed lines are referencing. So now on our elevations, we're going to flip over to an elevation view, which Kate talked a little bit about earlier. So this shows us it shows us our building heights. So we have some actual heights noted. It shows us our materials. Again, on this sheet, we do have specific keynotes, as well as a specific legend that tells us what our different materials are. So when you see the different kind of hatching looks, you can see exactly what types of materials those are, as well as typically what colors. So those are the kind of things that the architects will note on elevations. Another sort of industry standard thing to know, when you see section cuts, if you see a double-headed section cut, both of these reference the same one, that G1, that is actually a building section. Wall sections are going to be noted with a single head and this short little stubby tail at the end. So just a kind of clue there as to how to tell the difference between the building section and the full section. So we're going to jump over to a building section, which is this D1. So right here in the middle, we found our D1. We know it's a cross section. And again, as Kate said, as we're looking, this is a slice through the building. So this gives us a sense, we looked at the plan for kind of a sense of the layout arrangement. So the sections give us a sense of the vertical arrangement. What is the space doing vertically? What are the different ceiling heights doing? We can also start to see some of the building structure here. We're getting a little more detail. And we can see the MEP system here above the ceiling, all of the ducts and the pipes and everything that's running up above the ceiling. Not necessarily typical for an architect to show this, so you may see it, you may not. But again, please do join us for our next series where we do dive into a little bit more on that MEP. So now we are going to go to a wall section. So the building section kind of gives us a big picture view vertically. The wall section, as Kate mentioned, now we're drilling down even more into that detail and gives us more detail about what the actual wall is. So this is a vertical slice just through that wall. So again, can be confusing, a lot of information here, but we can rely on our keynotes to see what our different components are. We know we've got some bad insulation, we've got some gypsum sheathing, we've got some studs, we've got some sheet specific notes to pay attention to. So now we can start to see really how that wall assembly is being structured and what the different layers are in that wall. And then we can drill down even more. We have some enlarged details. So we have a clue here, right? This is that call out that says, hey, there's even more detail if you go and look at this specific detail. So if we click on that, we can now see we're getting even more detail. So this shows us how all of the connections are being made and how all of everything is being finished. So we can see the structure here, we can see how it's being finished. So again, as we get deeper into the set, we get to see more and more detail. Our details are kind of big picture details here. These enlarged details can be either a plan, a section detail like we see here, or it could be a plan view. So you may see on a floor plan, there's a call out for a small area, and it can show you how a lot of different walls are intersecting and how those connections need to be made. You'll also see details for how windows are installed. So we can see here how the window is going to be installed and how it's going to be made watertight. So we've got some, looks like we've got some caulking and some different things going on. So all good information to have. Page down. So we touched briefly on schedules. Again, we have more detailed information here. So the schedules are really specific information about specific components of the building. So in this case, it's the door. So we saw the door tags on the floor plan. So now we can come to the schedule and say, okay, we know that door that was in room, whichever it was, that door 1410, we can see a lot more specific information about that door. So it gives us information about what kind of hardware it has, how big the door is, what's the width, what's the height, what's the door made of, what's the finish of the door. Again, really specific information that you're not going to find elsewhere in this set. So as Kate said, each discipline will be scheduling different things. In the architectural set, you'll see door schedules, you might see a window schedule, you might see schedule for all the room finishes, tells you what goes on what wall, what paint, what carpet, what ceiling. And then the other disciplines will be scheduling their own specific building components. So MEP scheduling equipment, structural scheduling their columns and their foundations. So we'll flip over to now the interior elevations. Again, just like our building elevation view, now we're standing inside the room and just looking at the wall and seeing what's going on that wall. So the interior elevations will show you things like wall coverings and finishes. If you have tile, it's going to show you where the tile goes. It's going to show you plumbing fixtures and what various heights those need to be mounted at. And in our case here, we've also got some millwork or some cabinetry that's going in. We looked a little bit at the reception desk. So we can see we've got some dimensions, we've got some information on finishes. Again, we have a sheet specific legend that we can look at that gives us those Where's Waldo clues to know what those different materials are. And again, we can see we've got a call out for a section that shows us even more detailed information on that cabinet. And if we were to go to that, that's that H4. Now we can see how all of those pieces come together and how that cabinet is supposed to be constructed. So again, as we get deeper into the set, we're getting more and more granular on that information. So we're going to jump over to the structural set. And I wanted to highlight here before Kate jumps into our concrete and foundations, that the steel, each discipline is going to kind of have its own sort of cover page, its own general notes page. And here we have all of the abbreviations that relate specifically to the structural drawings. So as Kate said earlier, each discipline is going to have their own specific set of abbreviations. So what you see on the architectural drawings may not apply to the structural or mechanical. Some may overlap, but some are going to be very unique. The other really important thing I want to note here about the abbreviations is just because you see it on the page doesn't necessarily mean it's going to be in the set. So for this example here, cold formed metal framing doesn't necessarily mean we have cold formed metal framing on this project. This is really your reference back so that if you saw that CFMF anywhere in this set of drawings, you can come back to this and see exactly what that is. So Kate, I'm going to let you jump into the concrete and the foundations.
Perfect. Thanks, Tammy. Okay, so I'm going to grab over here screen share. Sorry, guys. Hey. All right. So can everybody see this page? Yes. Tammy, can you see it? Okay, perfect.
Gotcha.
Okay. So exactly what Tammy was saying. Sorry, I'm down on it. There's going to be, it's a 0-0 page. Okay, so that means this set is a discipline and it is the responsibility of your structural engineer. So the structural engineer is responsible for the dimensional controls of your building. The engineer puts together requirements. I'm going to talk about concrete. So he'll talk about everything that is absolutely crucial, necessary, and an absolute must on this in regards to concrete. So you'll see, again, multiple trades mentioned. So structural pages, we're going to see, concrete contractors, roofers, waterproofers, steel erectors, wood framers, masonry, roofers, but also your MEP subs are looking at these too to make sure that they have weight distribution for the skeleton of the building for really heavy materials. So we'll see that also. So really, I just wanted to show you all this page. So this is an isometric drawing. Okay, so these are amazing because it's literally a storybook of what your building is supposed to look like. So it shows you underground too. So what this is, okay, so this is a medical school that was teaching dentistry and doctor stuff. So we can see the concrete foundations. That's what these are going around. So your concrete foundations, and it's got a turn down foundation. Okay, so it's just going all the way around. You can tell that it's really here to support the steel and the roof. And then it kind of dips down, which tells me something's happening there. So I'm like, okay, mental note, where's Waldo? Figure that out later. And then, but then we've got the slab on grade, and then the canopy, it has its own footers. So even by looking at this without looking at anything else, I can tell the bones of this building. So I'm like, okay, got it. It's steel, it's concrete, it's canopy, amazing. So don't let these intimidate you, okay? So these are, again, you're gonna take that S00 page, you're gonna snippet this, hold it off to the side, print it, and so when you're looking at this, you know what these are, right? Okay, so it does give me a little legend. So the legend is telling me the X-XX indicates the top of wall footing elevation, so where it is on top. And then this one is indicating a spread footing. So it's a column footing, right? And then it will tell you the top of the footing. And then other than that, I'm going to read through the notes really quick, find those, where's Waldo's, start marking them in color. But really what I want to talk to you guys about today is what we're looking at. So remember the isometric drawing right here. Okay, so we see these column footers right here at the canopy. And here now they are on that overview plan view, and I can see exactly what they are. So they're pre-engineered canopy columns. Okay, tells me the engineer, they're typical. It's going to tell me information on it. It's 3 feet wide by 3 feet long by 3 feet deep. So 3 by 3 by 3. And then it tells me it's got a little strap, so it's connecting. And that is 1 foot 6 inch wide by 1 foot 6 inch deep. And then it's got some steel information. So it's rebar. So it's telling you the number of quantity is in front of the hashtag. So it's 22 by 7, which might be, y'all don't worry about that right now. Okay, so then we also see the slab on grade. Okay, so these are your individual footings. And I'm pointing like as if you can see my hand. So these are your footers. Okay, so and they have designation numbers. So this is footer F5.0A. And this is the exact same one. And this is F5.0A. So they're all the same, right? And then here's a different size one, F7. So I know, okay, that's different. Okay, so that's a different kind of footer. So those are your individual column footers. So a column footer is a vertical structure that carries the load of the slab. So typically, we saw on that isometric drawing that's holding up steel. So this is the location in which the steel is. So it needs some extra weight. And then from there, you'll see this like kind of lines that go around the building. So those are called a turn down, and they'll have their own viewpoint, which we'll look at here in just a minute. And that's a deep foundation. So that's this guy that's running in the way of the outside of the building, okay? So that's called a turn down foundation. And then everything in the middle is just your slab on grade. So you see like something that's extra dark and kind of called out. It says slab sloped for drainage. That is your engineer saying, Mr. Contractor, don't forget this. It needs a slope. It needs a place for the water to go down. So it's got mathematical rise over run, which is, using gravity built into the concrete to ensure that it goes where it needs to go. Other than that, we would go and look at 2 pages up. We go and look at here, and I see that CJ everywhere. So I'm like, what is CJ? It's a contraction joint. Okay, cool. And then so I'm like, I see all the CJs. It looks like there's a lot of those. What is that? And so we would go and check that 00 page. But that, we know that it is a concrete cracks, right? So we want a place for the concrete to crack. So by having that contractual joint or a control joint like sawed into your concrete or like embedded into your concrete, it's ensuring that you're not going to have big cracks in your building. They're hidden, so it's brilliant. Tammy, you want to take it from here?
Sure, I appreciate that. I'm gonna actually flip over to the set that I had so I can navigate around quickly. Oop, everybody can see I'm on Zoom. That's good. So the next page that Kate had flipped to is our structural framing plan, and our structural framing is really our skeleton of the building. So we've talked about everything that's holding up the building. Now we're looking at kind of what are the bones, literally the bones of the building. And again, this axonometric view is hands down one of my favorite because it really shows you how all those different pieces and components come together. So if we go to that framing plan, this is where we can get a lot of information. So we see these grid lines. We saw these on the architectural drawings as well. These center lines with designated grid numbers. These are showing us where our column locations are. And this is really our dimensional control of the building. So the structural engineer sets this, gets input from the architect that kind of coordinate how the whole building is going to be laid out. But the structural engineer really owns that grid system and that dimensional control of the building because they're the ones that are engineering those columns. So on our framing plan, this is going to be our roof framing plan. So we're seeing what's holding that structure up above. We're going to see some notes that refer to the different types of framing members. And if we go back to our axonometric view, right, we can see our framing members here running across the page. We've got some beams, we've got some joists. It looks like we've got some other types of members here. Not sure what those are, but we can go to our framing plan and we can figure that out. So the information that we get here, so our beams are typically going to be noted with a W. That's called a wide flange beam. So we'll see a W designation for beams. Joists are denoted typically with a K. There's a K series joist. You may also see an LS, which would be a long span joist. But those are going to be typically your joists. And then we're going to see this other member. Wasn't sure what that was, but now that I'm looking at our plan, I can see it's designated as an HSS. And I can go back to my abbreviations page and see that that stands for hollow steel structure. So that's typically some type of tube steel. So now we know what kind of members we have, but we also want to know what size they are. So the first number in each of our member sizes is typically going to be our depth of the structure. So we know, for example, this is a 16-inch deep wide flange. We know our first number is a 24. That's a 24-inch joist that's running across. Not sure what our HSS members are, but I can see, again, we've got some additional detail and information. I could click on this and it will probably tell me what size those members are. We're actually going to look at this when we look at this braced frame in just a minute. Don't have really information on what that braced frame is made out of. But we know we're going to typically see bracing in a building because that's the lateral stability that keeps it from moving back and forth, keeps everything locked in place. So we know we can go to this detail and look for more information about that. But before we do, a couple of other things to note. We have information about our roof deck. And it looks pretty simple, but what this is telling us is that our roof deck is spanning in this direction and it's an R. So I would bet we could come over here, either to our abbreviation page or nope, right here, here's our special note that's sheet specific that tells us our R. It tells us all the information about our deck, what type of deck it is, it's galvanized. So a lot of information there. The other thing that this is going to show us is where our loads are on the structure. So it's going to give us actual loads. So we know we have an RTU here that's 3,500 pounds that the structure has to support. I know if I go and look at my abbreviation page, I know that RTU stands for rooftop unit. So I know we have some mechanical equipment sitting up on the roof. It's 3,500 pounds and we have some point loads of 450 pounds and 950 pounds. So the structural engineer is going to take all of that loading into account as they're designing the structure. But important to know where those loads, specific individual loads, are being placed on that building. So those are going to be either things that are sitting on the structure or things that are hanging from the structure that the engineer has to account for. We're also going to see on this plan what our elevations are. So how tall is this building? So we can see here, we've got a DBE along this column line of 14'8". Again, I can go to my abbreviations page. I can see that DBE is deck bearing elevation. So I know that's where the bottom of that roof deck is sitting on top of the structure. So it's 14'8" here, but over here, it looks like it's 16'1". So these two elevations, these two are at different elevations. So this one is higher than this one. So that gives me the clue that my building is sloping, my roof is sloping down in this direction from left to right. So if I look at my architectural elevations, I'm not going to be surprised to see gutters and downspouts along this side because I know my roof is sloping, so my water is going to be running off the roof in this direction. We may also have specific components where it's just noted. This is what our elevation is. We have a little deck, roof deck, probably a canopy over an entrance door. So it's giving us information about that as well. All right, so let's go back to our bracing because we know we have an element here. We could see it in our axonometric section. Oop, I'm going down, sorry, gotta go back up. There we go. So we can see that bracing. So we've got a couple of members that are sort of going diagonally from the roof member framing down to the foundation. That's, again, that's keeping that lateral stability, but oh goodness, that's no good. Sorry. I'll get that to go. There we go. Sorry about that. Okay, so we don't know what that bracing is, but again, we can go to our enlarged view. We can click on that. We can see that A7, here's our braced frame. Now we get our member size. So we know it's a hollow steel section, it's tube steel. We know it's 5 by 5. And then we've got some additional loading information. Again, looking again, we have even more information. We can get even more granular in the structural drawings. We can see that's A12 S301. Well, we're already on S301. Here's our A12. So we can see a really granular detail about how all that is connected. We can see where our anchor rods are. We can see where our base plate is. We can look back at the symbol sheet for the structural drawings and see that these are weld symbols. So we know that some things are being welded together here. So this gives information on how those pieces are coming together, how they're going to be installed. We talked a little bit about schedules for the architectural drawing. I did want to point out, again, each discipline is going to have some schedules that are scheduling specific components. So here we're actually having all the steel columns scheduled. So we know what the roof elevation is. We can see the columns and where they sit above that elevation. Remember, on that elevation, we had 14'8" on one side and 16'1" on the other. So we know there was some sloping, so we can see which columns are which. And we can also see what base plate and anchor rods go with each of those columns. So we've got some more detailed information about those specific components here. And again, we have more specific details. So we'll have you'll see some foundation details, and then you'll see details for how those roof members come together. Again, whether they're going to be some bolted connections, which we can see called out, or again, we've got some welds, so we know those pieces are being welded together. So that's kind of an overview of the architectural and structural components. Thank you guys so much for joining us today. To wrap up, I really wanted to highlight a couple of, I think, are the key takeaways. It's important when you're reading the drawings that they're taken as a whole. So your architectural drawings are going to be referencing your structural are going to be referencing your architectural. We saw some mechanical drawings or information on the roof plan or the structural framing plan. So we can go to the mechanical drawings to look at that. So you've got to really take everything as a whole to give you that full picture of what's going on in the building and how it's all coming together. And again, when it seems really overwhelming and there's so much information on that sheet, just take it piece by piece. Look at that in large detail, kind of get granular on that, then come back to the overview and take another piece and kind of work it through. And that'll give you an easy way to sort of see how all those different pieces are coming together, and allow yourself that time to flip back and forth between the drawings. Keep multiple windows open if you need. If you've got two screens, it's not uncommon for me as I'm looking through plans to have two different versions of Bluebeam open with two different disciplines so that I can be looking back and forth. And always remember to check not only the abbreviation sheets, but look for those additional Where's Waldo clues on those specific sheets for your specific legends, your specific keynotes, and then your project specific notes. So thank you all again so much for joining us. We have a few minutes for questions. So if you want to pop those in the chat, or if you want to take yourself off mute, we're happy to answer any questions you've got on what we covered today.
Yeah, I know that was really quick, guys, but we do really appreciate it. This was really just kind of the point of view of why and what we're looking at. And I think the biggest takeaway while y'all are coming up with questions is every discipline. So again, that's civil, structural, architectural, mechanical, electrical, plumbing. Each one of those is going to have a 0 page or their first page. That's going to have a legend. That's going to have usually schedules, and it's going to have a lot of information on the rules, what you're allowed to do, what you're not allowed to do. A lot of CD sets do include specifications on those pages. Always read those. Those are not just boilerplate, copy, paste, repeat. No, they sure could be. But it's always good to go through them because that's where they hide the money. That's where the trades are going to sit on top of each other. And, you know, perfect example, I've been electrical. We call it chasing masons. So like when we have to do our rough-in, a mason like installs a wall 4 feet at a time throughout the whole week. And my electrician has to go over there and like move the little box to make sure that it doesn't get bumped and ran. That's a high cost, you know? And so like if somebody doesn't think about it, you know, how that relates to the field at that pre-con side, then you can lose some money. So, you know, all those detail views and those section views when Tammy was digging into those, that's where your trades interact. That's where your scope is. That's where your information on your material is. So that's what we always wanted to look at. Miranda asked if we would have access to the recording. So we can find out. That might be a NAWIC national question. Do you want to fill them in on next session, Tammy?
Yes, so April 9th at the same time, so I think that's 12 p.m. Eastern, 11 a.m. Central, we will be doing the second session of our blueprint reading, which will be covering the mechanical, electrical, and plumbing drawings. So we'll take a little deeper dive into those drawings and to how to sort of navigate those drawings and figure out what all that information is as it relates to those disciplines.
Oh, we got past president in the house. What up, Laleen? And then those who don't know, Southeast Forum is April 4th through the 6th. So come on down to Nashville.
So for those of you not monitoring the chat, it says the recording will be uploaded to the website. So you should be able to have access to the recording.
Thank you, Savannah. Perfect. Yeah, see you in Nashville. And then annual conference tickets are already up for sale. So come join us in Houston. I'll be there. Tammy will be there.
Looking forward.
Pauline will be there. All right, perfect. I don't see any questions coming up. Yeah, Amy, me and you can get together, girl. She's on my chapter. But yeah, nope, just basic overview. We'll talk about it. You know, we're gonna have a class in Atlanta anyways. But yeah, okay, perfect. Well, I don't think there are any other questions. So we will see you April 9th. Hopefully I see some of you in Nashville on the 4th. And other than that, there's our contact information. Shoot us an email, find us on LinkedIn, and let us know if we can help further. But other than that, we'll see you guys later. Thank you.
Thanks so much, guys. Bye.